Away we go. This is the unit circle. Okay, then we're going to start. We're going to take our protractor here, or our compass rather, and we're going to measure out 3 3/4 inches on our ruler like this, and then we're going to make a big circle on our paper. It should be 8.5 or 8 by 11, so that should get you on your paper. So a big 3 3/4 inch circle on your paper. Go ahead and mark the center, and then draw a nice circle there. Here we go.
How open do you want to have it?
3 3/4.
3 3/4 inches is what you're going to measure. And then you're going to draw in the diameter. There is the diameter. Using your protractor, you are going to mark 90 degrees up and down. And you are going to draw in that diameter also. All right. The idea of the unit circle is that the radius is 1 unit. From here to here is 1. Now, I know it's not 1 inch, it's not 1 foot on your paper, it's not any value measurement that we know, but we consider this to be 1 unit. That is the overriding theme of the unit circle. The radius is 1 unit. What we do is we put radians on here, we put degrees on here, and we also put ordered pairs on here, which we'll get to. All right, so here's what I know. This is 0 degrees. Oop, I'm going to use a different color here to help myself out. I'm going to go 0 degrees, 90 degrees, 180 degrees, 270 degrees.
That's money.
I'm also going to go radians. Oh, and sorry, 360 degrees.
You want a paper like this or like this?
It doesn't matter. Just get it on there. And then I'm going to go around and put the radians. So 0 degrees is 0 radians. And 90 degrees. And 180 degrees. And 270 degrees. And 360 degrees has a number of radians also. 360 degrees, we should know by now, 1 full revolution, how many radians?
2.
2 what?
Pi.
2 pi radians. I'm not going to put radians after each. When you see the pi, you'll know that's the radians. It's 2 pi radians. 180 degrees is half of 2 pi radians, which is pi radians. 90 degrees is half of pi radians, which is pi over 2 radians. And 270 degrees is 1.5 of the circle, or a revolution and a half. A revolution is pi, and I add that much more on. I add a half a pi, so I take 1 pi plus a half a pi, and I get 3 pi over 2 radians. Those angles are called quadrant angles. If it ever says list out the quadrant angles, that's what it's talking about. It's talking about listing those guys out. Well, on the unit circle, we have so many more marks to come up with. So here's what I want you to do. You're going to take your protractor here, and you're going to measure. You're going to put a little tick mark at 30, a little tick mark at 45, and a little tick mark at 60. And you're going to do that in every quadrant. 60, 45, and 30. And 30, 45, and 60, and 30, 45, and 60. And you're going to use those little tick marks to draw in a whole bunch more radii. So here's one. And we're going to go around the circle like this, drawing in these radii. 30, 60, and 45 is what we're going for. Should go through the center each one of those and through the tick mark on the other side. So you have that picture next. 30 degrees, 45 degrees, 60 in each quadrant. Should be drawing this with a compass, ruler, and protractor right now. See how everybody's doing. Take your time, draw these in. About a minute, I'm gonna start putting things on those, so make sure you have them all drawn in. Draw the radii in, mark your center, draw in the lines. Here we go, Jackie. All right, that is just the skeleton of the unit circle. What we need to do is we need to put a whole bunch of measurements on this guy. Okay, I'm gonna go from easy to hard. The easy is, okay, what are the degree measures? Okay, 0 degrees, 30, 45, 60. 0 degrees, 30 degrees, 45 degrees, 60 degrees, plus 30, 90, plus 30, 120, plus 15, 135, plus 15, 150, plus 30, 180, plus 30, 210, plus 15, 225, yep, plus 15, 240, plus 30, 270 plus 30. What? 300 plus 15 is 315 plus 15 more is 330. We know we got it right is because we add 30 more and we get to 360. Those are the degree measures that go with the unit circle. You need all of those degree measures on there. Now, I would use multiple colors for this. I like to make my colors pop. So I use degrees, I'm using pink. And then I'm gonna go to blue. I'm gonna go to the radians. And I probably, like I said, I won't put the word radians on there. Sometimes I see R, sometimes I see people put rad, R-A-D, whatever. I'm just gonna go in there and find those, okay? All right, the first thing I wanna do is I wanna figure out, and I do these in a little bit different order. I don't like just go this one, this one, this one, this one. We're gonna go by a set number, and what we're gonna do is we're gonna change by 30 degrees. Because watch what happens. I change by 30, I change by 30, 30, 30, 30, 30. I hit all of these ones that change by 30. And you might notice if I got rid of all the 45s, I would have these little 30-degree slices of pizza. I'd have a 30-degree slice of pizza, a 30-degree slice of pizza, a 30-degree. And if I can just change by the same amount, I think I can come up with a pattern that makes it really, really easy to go ahead and write in the radian measure. So the first one is here at 30. You may or may not know what 30 is. Let's do our conversion. Radians over degrees equals pi over 180. So my radians is I don't know x. My degree value is 30. I have pi over 180. And then I'm going to cross multiply. 30 pi equals 180x. I'll divide by 180. I'll divide by 180. And my x value is whatever 30 pi over 180 is. Can anybody do that fractional math where you reduce 30 pi over 180 into what it is? Pi over 6. Because the zeros wipe out, and 13 over 18 is 6. So this is literally pi over 6 radians. Pi over 6 radians is what I get there. Now I'm going to do this twice, and then we're going to see the pattern. And after we see the pattern, we're going to do the pattern, and we're going to write in our answers. That's definitely pi over 6 radians. All right, I want you guys to do the one at 60 right now and see what you get. Radians over degrees equals pi over 180. See what you get, and then we'll write it down.
What is it?
You guys doing it. Radians over degrees equals pi over 180. X over 60 equals pi over 180. 180x. 180x equals 60 pi. I'll divide by 180. I'll divide by 180. What is 60 over 180 reduced to?
3, 1/3.
1/3, right? So this is actually pi over 3. Huh.
The 45 one.
But wait, we're going to skip that one for now. But wait, look what I see. This is 0. This is 1 pi over 6. What does 2 pi over 6 reduce to? If I said 2 pi over 6.
Pi over 3.
Pi over 3, right? So this is 1 pi over 6, 2 pi over 6, which reduces down to pi over 3. What would 3 pi over 6 reduce to? Pi over 2. So it literally goes like this. 0 pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6. And if we just think about changing every 30-degree increment is changing by pi over 6, we can get all of the radian measures of those 30-degree spots by simply writing them as pi over 6 values and then reducing the fraction. Again, here's what I'm talking about. 0 pi over 6, 1 pi over 6. This is really, don't write this, but it's really 2 pi over 6. That reduces down to pi over 3. And this one is really 3 pi over 6. I changed again. 3 pi over 6 reduces down to pi over 2. So here we go. Let's see if we can do this. Here we go. 0 pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6. Okay, what would this one be?
4 pi over 6.
4 pi over 6. What's it reduced to?
2 pi over 3.
2 pi over 3. 4 pi over 6. What's that one?
5 pi over 6.
5 pi over 6. 5 pi over 6 reduce?
No.
Nope. So this one is 5 pi over 6. Okay, let's try it again. 0 pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. This one right here should be what? 6 pi over 6. Reduce.
1 pi.
Pi. 5 pi over 6. 6 pi over 6. This one.
7 pi over
7 pi over 6. Reduce.
No.
7 pi over 6. That one's 7 pi over 6. This one.
8 pi
8 pi over
over 6.
6. 8 pi over 6. Not 8 pi over 6. We're not going to write it like that. We're going to write it as 4 pi over 3. It is fractional math. Okay, so 6 pi over 6, 7 pi over 6, 8 pi over 6. This one right here,
9 pi over 6.
9 pi over 6. 3 pi over 2 if you reduce it. So 9 pi over 6. This one right here, 10 pi over 6. Ooh, 10 pi over 6 reduces to 5 pi over 3. 5 pi over 3. That's 10 pi over 6. 10 pi over 6. This one right here, 11 pi over 6. And that one right there would be 12 pi over 6, which is 2 pi. So I got the radian measures of all of my unit circle spots that are 30 degrees. Well, we need to do this for 45 degrees also. Okay? So let's go up here on the 45 degree one, and I want you guys right now, if you don't remember it, to do radians over degrees equals pi over 180 and find the radian measure at a 45 degree angle. Go if you don't know. You guys do it. Radians over degrees equals pi over 180. So there was that one. There was that one. And I'm going to do radians. X over degrees 45 equals pi over 180. And then you got to reduce 45 over 180 on your calculator, or maybe you know how many times 45 goes into 180. What is that change? That here to here, how big is that in radians? Pi over 4, yep. So that's a pi over 4 measure right there. That's pi over 4. Okay, 180x equals 45 pi. Divide by 180. Divide by 180. 45 over 180 is 1/4. So it's pi over 4 is how we write it. So what that means is every time we switch 45 degrees, if I'll switch 45 degrees, I'm going to gain pi over 4. So here we go. Watch this. 0 pi over 4. 1 pi over 4. What should this one be?
2 pi over 4.
2 pi over 4.
Reduced.
Pi over 2. 0 pi over 4. 1 pi over 4. 2 pi over 4. 3 pi over 4. 4 pi over 4. This one. 5 pi over 4. 6 pi over 4. 6 pi over 4 reduces down to 3 pi over 2. This one, 7 pi over 4. 7 pi over 4. And then this one up here would be 8 pi over 4, which would just be pi. 2 pi, or 2 pi, rather. Let's look at some things that occur in here in terms of radians. I think the degrees are pretty easy. We've all been playing those video games that we spin things and we know degrees pretty well from geometry and whatnot, but the radians are new. So first of all, everywhere there's a 45 degree angle, there's an odd pi over 4. 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. 1, 3, 5, 7. You should introduce that. 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, odd pies. Okay? Coming up from the x-axis on both sides. The first one, what pi over do you notice? Pi over 6s. These 30 degrees based off the x-axis are your pi over 6 spots. And then these ones coming up here, the 60 degrees off the x-axis, 60 degrees off the x-axis are all my pi over 3, 2 pi over 3, 4 pi over 3, and then 5 pi over 3. And man, there's a lot of ways I can count on this. Watch this. I could count by pi over 4s. 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. And I could reduce those fractions. I could count by 30 degrees. 0 pi over 6, 1 pi over 6, 2 pi over 6, which reduces, 3 pi over 6, which reduces, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6 is 2 pi. I could even count by 60 degrees. 60 degrees is by pi over 3. Watch this. 0 pi over 3, 1 pi over 3. Change 60, 2 pi over 3. Change 60, 3 pi over 3. Change 60, 4 pi over 3. 5 pi over 3, 6 pi over 3, which gets me to 2 pi. There's a lot of ways to do that. Okay? That's part 1. That is radian and degree measures.